So today's math lesson is lesson 30, session 3, and I'm actually going to begin instruction on page 656. And we are currently exploring different ways how to understand how to identify angles. So the first thing that you need to learn is what a right angle is. And a right angle is the angle where two perpendicular lines, or in this case, these are both rays because they have a starting point, where they meet, if they are perpendicular, this measurement right here would actually measure 90 degrees. So a right angle is where two perpendicular lines meet, or rays in this case. So if I think about this square of paper, I know that each of these corners is 90 degrees. And I can prove that by lining it up right here between those two rays. So I know that this is a 90-degree angle on this piece of paper. This is a 90-degree angle, this one and this one. So a square and a rectangle consists of four 90-degree angles. And because it has four 90-degree angles, we can multiply that to get the total degrees that the angles measure in all. And that would be multiplying the 90 degrees by 4, and this will give us 360 degrees. Well, 360 degrees is a magic number because it is also the measure around a circle. If you think of it like if this were a compass, compasses are measured in degrees, and that is basically based on this idea of 360. So 0 would start at the top of a compass, and it's also 360 because that would be one whole revolution in degrees around this circle. Now, what is unique also about a circle is I could take this circle and fold it in half, and I can fold it in half again. And can you guys see what I've created right here? What I've made? I've actually made a 90-degree angle by folding this circle in half 2 times, and I could actually use this to measure some of my the problems that we're using to see if they were 90 degrees. So like I told you, similar to a square, a circle measures 360 degrees. And I have this one, you can kind of see it right here. I have this 90 degrees right here. I have this 90 degrees right here. So from north, if this was a compass, from north perfectly to east is 90 degrees. And remember, we start at 0 on north. This would be a 90 degrees. And then this would be south if this was, a compass. So the measurement from north to south would be 90 plus 90. So that would be 180 degrees. And we have west over here. So we have the 90 plus 90 plus 90 would give us 270 degrees. And then all the way back to north would be 360. That is because you could measure the 4 right angles that are inside that circle. So I'm going to hold on to this and help us try and figure out some of these measurements here. Okay, this is the angle shown at the right is a right angle. A right angle has a square corner. And usually in math, angles that are right will go ahead and put this square here for you. So you will always know if you see an angle with a square in it, or partial where it makes a square, that is a 90-degree angle. And now the problem says to look at the figure below and name the rays that make up each of the angles listed. So what ray makes up the right angle? Well, we know that the right angle is going to be this measurement here. So that the rays that make this up are going to be ray, remember we start at the end point. So this is going to be ray BC and ray BE make up this right angle. And number 2 says an angle that has a smaller opening than a right angle. Well, we actually have 2 of those. We have this angle right here is smaller than the 90-degree right angle, and we have this angle right here. So we have 2 angles. And we can write those as being, remember, you have to look at the vertex, which is B for both of them. So we have angle, I'll do it down here, angle CBD, CBD. And remember the vertex goes in the middle, and angle DBE. Make up two angles that are smaller than the right angle. And number 3 says an angle that has a wider opening than a right angle, but does not open as wide as a straight line. So we can't do the straight line, and it has to be bigger than this angle here. So we have to kind of look at this problem now differently. And we have to look at it, if we start over here and try and find an angle, we actually see that we have this angle right here that is going to be bigger than a right angle. Because if we look on this side, this could also be a right angle, and then this angle would be larger than that right angle. And that would be angle, we could call it DBA or ABD. I'll call it ABD. It's going to be larger than this right angle. Now, in order to help yourself figure out these types of problems, you can always make a drawing to help you identify the different types of angles. And you can see here, as I tried to do in colors before, that the area within here is less than 90, and the area within here is less than 90, the angle. But when they're both together, they actually do make a 90-degree angle. And if there's a 90-degree angle on one side, there has to be a 90-degree angle on the other. So then this angle over here, angle CBA, is also a right angle. Okay, so let's go ahead and move on to page 657 and try to define a few things that we've done so far. So the model, it shows a right angle. Draw a right angle, then using 3 points to name a right angle in the figure on the previous page. So then use 3 points to name a right angle in the figure on the previous page. What I'm gonna do is I'm just gonna go ahead and draw my own and give it points. I'm going to use that piece of paper to outline. Okay, so I know this is a right angle because I measured that. Even though I drew it a little slanted, it's still a right angle. And I'm going to draw a ray, and I'm going to label some points on this. And really, you can label them whatever you want. So I'm going to label this one, let's go D, E, F. So I have point D, point E, point F. I have ray EF, ray ED, but I have angle DEF. And as you're looking at these objects, I encourage you to try to find all the different ways you can look at it. Like I said, there's also ray EF, and there is ray ED. And you can also see segments here. If we wanted to say we could see a segment from this point to this point, could be segment EF, line segment, and from this point to this point, it could be line segment ED. So an angle that has a smaller opening than a right angle is called an acute angle. So acute angles are smaller, just write smaller than right angle. And you can think of them as, oh, they're so small, they're cute. So anything smaller than a right angle is going to be, oh, cute, acute. Name an acute angle on the figure on the previous page. So I'm going to show you that drawing right here again. And we know that our acute angle is going to be this one and this one. So that would be CBD and DBE. So in an angle that has a wider opening than a right angle but does not open as wide as a straight line is called an obtuse angle. So obtuse is larger than a right angle. And you can always put that as an angle sign, larger than a right angle. And we said that on the previous page, our right angle that was larger is going to be, when we look at it just a different way from left to right, we can see it as angle ABD. That is larger than a right angle. Explain how you can decide whether an angle is acute, right, or obtuse. Well, you can use, number one, you could use something that has a right angle on it already, so that way you can kind of compare, or you can see if it's small or large, right? So let's see here. So a small angle like this, I know, is much less than what maybe a right angle would be, which could be up to here. So this one will be acute, and anything that's opening its mouth really big and wide, you can think of a big wide mouth open, is going to be obtuse, because we know that it is definitely greater than a right angle. And I can show you guys how I can use my own line or my own little template here to show you that it is greater than the right angle, because this would be a right angle right here. All right, so let's turn to page 658. And this one says, how many acute angles are in the shape below? And explain how you know. Well, just by looking at it, because I don't see any of the squares at any of the angles, I know that there are no right angles. So, and I can use my template to kind of see if, so that angle we can tell is very small. That is not a right angle, or that is an acute angle. And this one would have to go up right here if this was a right angle. So this angle is smaller. And this angle also would have to go out to here to be a right angle, so this one is smaller. So there are actually 3 acute angles in this triangle. Look at the shape below. How many obtuse angles are in the shape? Explain how you know. Oh, I forgot to explain. So there are 3 acute angles. They were all less than 90 degrees. So let's now look at our next object, and I'm going to our next shape rather. I'm going to put my template at the corner here, and I can see already that this angle goes larger. And let's look at this angle right here. This angle is larger. Let's try this one. Looks shorter, right? Because this goes inside, and this one is shorter. So I know that this angle and this angle are obtuse angles. And I know that because they are larger than 90 degrees. Remember, that is a right angle, is 90 degrees. So now I'm just going to look at these angles here, and I think you can tell just by looking at them which one would be obtuse. And remember, that means larger than 90 degrees. We can see that D clearly is open up a lot more than the other ones. And I know just by looking, this one's cute because it's a cute little angle. It's smaller than 90 degrees. And I'd actually probably have to measure A and C to see if those measured 90, but I'd also hope that there would be a 90, the little square representing it if they were 90 degrees. And that includes today's lesson. You are going to be able to now work on your bookwork on page 659 and 660.